Hello, and in this installment, we're going to look at a PhET applet called Balancing Act. And as I've introduced to you previously, we have the fulcrum here, the seesaw, and we have this mass of the fire extinguisher and this mass of the fire extinguisher, and there are these numbered marks that are given to us. So, and it comes as no surprise to us that this would be balanced. Let's make some modifications and see what happens. Let's move this one here to say location 6. And we release it, and we can see it moves in this direction, which is a negative omega. So the torque on this was in this direction, which is not surprising given that this one was farther out. So let's just replay that again and watch how it moves. All right, let's move this fire extinguisher again to here. Now, of course, you'll notice it again had a negative omega, but you may also have noticed that it moved more quickly. It underwent more acceleration because there was more of an unbalanced torque. And we move it there. And again, no surprise, a negative omega. And again, it went even more quickly. So now let's replace this 5 kilogram with a 10 kilogram. And of course, we expect that to win quite handily. But what about when I move it in here? And here. Whoa, there is something about this that is equal. The torques in this case are equal to each other. And some of you who just happen to notice the numbers may have noticed that 5 times 8 is 40 and 10 times 4 is 40. So they're equal to each other. The torques are equal. This 10 has a torque this way, has a torque that's negative, and the fire extinguisher has a torque that's positive. Positive 40 and negative 40 add up to 0. So now we could probably predict what would happen here. We have 10 times 3, which is 30, in the negative omega, and we have 40 in the positive omega. So we expect that the fire extinguisher should win this time. Now, what if I do this? Is it possible for me to put 15 kilograms on here? Well, wait a minute. Let's see. There's a torque over here from the left fire extinguisher of 40. So we have a positive 40. And here we have a minus 20. And here is a minus 40. So moving this in like so, we now have a closer setup here. Let's see if we can see why. This side is 30 and 20 is 50, whereas this is 40. So then it stands to reason that if I move it closer, it will be even more close to being balanced. And so 5 times 5 is 25, and 20 is 45 when this is 40. So when I bring this 5 here, it should be balanced. 5 times 4 is 20, plus 20 is 40, and over here we have 40. And lo and behold, they balance. They balance indeed. Let's try another kind of crazy combination. Let's say we put that there and that there. Let's see if it's possible. Is it possible to balance this? And if so, where? Well, let's see. 10 times 1 is 10. 5 times 3 is 15, so that's 25. 15 and 10 is 25, so it should balance if we put that there. Lo and behold, it balances. And you can see then if we put this 10 here, we now have 20 plus 15, which is 35, and this would need to go to 7. Sum of the torques. The sum of the torques is 0. It will not accelerate.